Hello, my name is Evie, and I'm a second-year engineering student studying creative technology and design at the University of Colorado Boulder. Today's lesson is all about different types of weathering on rocks, and I have HelperBot here, who likes rocks a lot, to help out. First off, why do we care about the strength of a rock in the first place? Well, there can be many reasons. One reason is that when a large rock breaks, it can be a huge hazard and possibly cause a disaster. Some disasters that include or are caused by falling rocks are earthquakes, volcanoes, and landslides. Knowing the strength and characteristics of a rock allow us to be able to predict or prevent such disasters. Another reason for why we might need to know the strength of a rock is for development, like building new schools or homes. Many buildings need deep foundations, which means the builders need to excavate the rock to build a good foundation. To figure out how strong a rock is, geotechnical engineers often drill into the ground and collect rock core samples. They examine the rock's texture and structure, and then use special machines to test how the rock responds to different kinds of stress. These tests help engineers make safer decisions when designing roads, bridges, buildings, and tunnels. Now, what can cause a rock to break? That's right. One method is the use of pressure. A lot of pressure can cause stress for a rock, and that stress can cause a rock to break. Sometimes, the natural movements of the Earth's crust can cause such stress. However, not all rocks break under the same pressure. Some rocks are easier to break than others. The strength of a rock depends on its type, its texture, and its chemical composition. It's also dependent on if there are fluids or not, or if there are internal structures within the rock. Sometimes, it's even possible to predict where a rock will break. They often break along planes of weakness, which is, you guessed it, the weakest part of the rock's structure. We know that pressure causes stress, which can cause a rock to break, but did you know that there are different types of stress? The first type of stress is compressional stress. This happens when a rock is pressed together into itself. When the Earth's crust moves, it can cause two rocks to squeeze another one between them. One example is how mountains are formed at a convergent boundary, like the Rocky Mountains. The rock is compressed and pushed upward, helping form mountain ranges over time. Try pressing your hands together. Your palms are being squeezed by compressional stress from the muscles of your hands pushing inward. Something similar to this happens to rocks. The second type of stress is tensional stress. This happens when a rock is pulled apart. Let's say a rock had wedged itself into the crack of another rock, and the movement of the Earth's crust caused it to go further until it broke. This is an example of tensional stress. An example of this is the Mid-Atlantic Ridge, which was formed at a divergent boundary by two tectonic plates pulling apart from each other to allow lava to flow up. Try pulling on one of your fingers. That finger is being pulled one way by your other hand, while that finger is still attached to the hand that is holding it in place, causing tensional stress. The third type of stress is shear stress. Shear stress is when a rock is pulled on one side but pushed on the other side. They're basically rubbing against each other with a large amount of force as they're trying to move in opposite directions. The San Andreas Fault is an example of this. It's on a transform boundary, with the California plate moving south and the Pacific Ocean plate moving north, causing shear stress as they're moving against each other. Try putting your hands together, but press upward with one hand and downward with the other hand. If you press hard enough, the skin on your hand should be pulled in the opposite direction that your hand is moving in. This might be easier to see if you press and pull with your palm on your cheek or arm instead, where the skin is a bit looser. This is an example of shear stress. Stress from movement in the Earth's crust isn't the only thing that can break rocks. Another process that breaks rocks is called weathering. Weathering are conditions in nature that break rocks down into sediments or smaller bits of rock. There are three types of weathering as well. Physical weathering is when a physical action breaks the rock, such as forces of wind or water. wind and water can be a lot stronger than you might think, especially when they're consistently battering something over time. A common example of weathering with water is how water freezes and thaws in the cracks of a rock. When water freezes, it expands, causing pressure and therefore stress that breaks the rock. Chemical weathering is when the rock is chemically broken down. A couple examples of this is when rust forms on granite or when acid rain breaks down limestone. This kind of weathering doesn't cause stress because there is no pressure on the rock, just chemical reactions. Biological weathering is when living organisms break the rock. A common example of this is a tree root breaking a rock due to the stress and pressure its roots cause within the rock. Don't forget to bring the items that you care about back inside if you left them outside, otherwise the weathering might get to them after a long while. Now that we know the different methods of stress and weathering that may break a rock, let's take a look at what rocks are made of. Rocks are made of minerals and are classified into different types depending on the composition of the minerals and the formation of the rock. A mineral is a solid material that exists naturally on Earth and is made up of only one substance, unlike a rock. Minerals are made up of many crystals, which are solid 3D patterns made by the molecular structure that makes them up. There are a lot of different minerals, and they are often classified by their chemical makeup and crystal shape. Some familiar minerals may include gold, silver, sulfur, mercury, and diamond. Minerals are identified by conducting many tests and comparing the results to charts of known mineral characteristics. Color, streak, the color of the mark they may leave when you rub it on something, transparency, hardness, luster, how shiny it is, cleavage, how the rock may break, and crystal shape are all characteristics that these tests look at. Rocks, meanwhile, are a bit different from minerals even though they might look similar. Rocks, rather than minerals, are made up of two or more minerals. Now that we know what rocks are made of, how are they made? There are three different categories in which rocks are sorted by how they're formed. Sedimentary rocks are made of sediments, as the name suggests. Sediments come from the weathering and erosion of old rocks, from influences such as water and air. This is called erosion and is the breaking down of the movements of parts of the Earth's surface. Weathering and erosion often work together to break down and move rock materials. After all the sediments are broken apart, pressure then pushes them together in a process called compaction in order to make a layer of rock. The salts crystallize in the rocks as the water is squeezed out, which is cementation holding the sediments together. Much later, the other sediments get pushed into another layer of rock and the process happens again. The bedding continues to layer more rocks on top in order to make a bigger rock. This makes sedimentary rocks quite easy to recognize, as all of their layers are often visible. Some examples of common sedimentary rocks are sandstone, limestone, and shale. Igneous rocks are made of magma, or molten rock. Magma is called lava after it comes out of the crust, like from a volcano. Then, it cools, forming an igneous rock. Different types of igneous rocks are formed depending on how they cool. Intrusive cooling is when the igneous rock cools slowly beneath the Earth's surface. Extrusive cooling is when the igneous rock cools quickly above the Earth's surface instead. Some examples of common igneous rocks are basalt, granite, and obsidian. Metamorphic rocks are formed from any type of existing rock. Pressure and heat change the molecules themselves of a rock's minerals so that it becomes an entirely different rock. Without melting, of course, as that would become an igneous rock instead. It's sort of like a butterfly's metamorphosis. The type of metamorphic rock that forms after the process depends on what kind of rock it first started out as. Metamorphic rocks often have the characteristic of foliation, which is where the pressure squeezes the minerals into a rock to create lines in it. Some examples of common metamorphic rocks are slate, marble, and schist. Remember the planes of weakness we talked about earlier, which is the point where a rock will typically break when pressure is applied? Well, some of these different types of rocks have different planes of weaknesses. Sedimentary rocks have them along their bedding planes or between layers of sediment. Meanwhile, metamorphic rocks have planes of weaknesses along their foliation planes, which are layers formed under pressure. You know how living beings often have a life cycle? You'd be surprised to know that rocks have their own sort of life cycle as well. Yes, really. New rocks are often made from old rocks, which gives us the idea of the rock cycle. Take a look at this diagram. Under certain conditions and processes, a metamorphic rock can change into a sedimentary or igneous rock, and vice versa. Every rock can become every other type of rock under the right circumstances. Now you know all about the properties of rocks and how they're made. Engineers find this information very helpful because knowing about the materials and environment that they're working with allows them to come up with the best possible solutions. Maybe one day this information will be helpful to you as well, and you can build strong buildings or prevent rock-related disasters. Wouldn't that be cool? Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the Teach Engineering website. Then, check your knowledge of material stress and rock properties in Soapy Stress and Rocks, Rocks, Rocks. Test, identify properties, and classify.